Hi, good evening, everyone. Today I'm going to go ahead and discuss with all of you what a data scientist does and what I did as a data scientist with IBM. Now, a typical day in the life of a data scientist has multiple things that we go ahead and do. So, usually, the first thing that we go ahead and do is we talk with a client. Say, for example, if my client is, let's say, I'm just giving a random example. If my client is, say, from power industry and they want us to predict what is going to be the electricity consumption for the next 4 months, then the first thing that I have to go ahead and do is I have to talk to them and I have to extract data from them. Now, whenever we get data from a client, this data is going to go ahead and have a lot of outliers. It is going to be messed up. It's not going to be very clean data. So you have to get your hands dirty with the data. For example, there may be days when the electricity is going to be very high, peaked up, because that's a festival and everybody is at home. And there may be, so it's an outlier actually, right? So similarly, there may be days when the electricity may be very, very low due to some reason. Right, or the consumption may be very high because there are board exam and the students are studying all night. So I'm just giving you one example. So there may be some outliers to the consumption of electricity from the past data. What you have to go ahead and do is you have to start cleansing the data and remove these outliers from the data. Then there may be some missing points. They may not have data for all of the for all of the days. There may be some days in which the data would be missing. You have to take care of that also. Now, electricity consumption will depend on a lot of things, right? But at the same time, electricity consumption will be given to you over a time period. So it will also have time series element to it. So then you have to start thinking what kind of prediction you can go ahead and do for the next few months. Would it be a prediction that can be done over regression? Or would it be a prediction which would require some amount of machine learning? Would it be supervised machine learning? Would it be unsupervised machine learning? So you don't usually go ahead and do one model. You go ahead and you build multiple models on the data that is given to you. And then, so for example, from the entire data set that is given to you, you split the data in 3 phases. The first phase is the phase in which you're going to go ahead and you're going to train the machine with. The second phase is what you're going to test the machine with. And the third phase is for the error that you're going to go ahead and account for, which is going to be your test. It's part of the test set, but that is where you want to go ahead and minimize the error, right? So for example, if I have a data from say 2004 to 2020, maybe 2004 to 2010 can be my train set, and then I can have my test set out of which I can try to minimize the error term. So I'm going to go ahead and do that. Now, once I go ahead and do that, I'm going to run different models on the training data and see where the error is getting minimized for the test set. Now, there are going to be multiple ways in which we can measure the error also, right? So we have to use all those elements and we have to go ahead and tell the client why we used a particular method to minimize the error term. Once that is done, we are going to go ahead and sometimes also use a weighted average of 2 or 3 methods, right? So I may give some weightage to linear regression and I may give some weightage to machine learning. Within machine learning, I may give some weightage to different models. And then I may come with a weighted model and say this is the best model to predict your electricity for the future. Within that, which weights are you using and how much weights are you using, that also needs to be justified to the client. So this is a snippet of what we used to do on a daily basis.